The manifold gauge set. We're going to start from the old and go all the way to the new, but these manifold gauge sets are essentially what we still work with today. This particular manifold gauge set I inherited from my great-great-grandfather, who was also in farming, ranching, real estate, construction, and HVAC. I've kept it in the original box as well as I could, but they're still very similar in how they work. We have our pressure gauge, which is useless. We convert that to a saturated temperature, and these had a saturated temperature chart with them. This one worked for 502, R12, and R22. Very simple 3-port manifold gauge. These old hoses that I'm sure would blow out if I tried to use them today, but still the same manifold. So I keep these for nostalgia. HVAC's been in my family for a while. But we're going to go on to what we saw in the videos. Earlier in the videos, you saw me using these manifold gauge sets. And what I did was purposely cut them apart because I wanted you to understand and appreciate the high side gauge is for the high side of the system, and the low side gauge is for the suction low side of the system. That even though they're in the same housing, they are two entirely separate gauges. I found that students sometimes struggle with that concept, so that's the idea behind this. So let's break down how this thing works. So here we have our main hose connected, and this is where we connect to the unit. So if I unscrew this port, this connects to the unit. The one straight down is the one that's always connected. On this particular model, it has this extra option in the front, and that's what's holding our hose to keep it clean. This port doesn't go anywhere, it's just a hollow end port. If we look on the mid port that I've also cut apart, we can see there's no light in through that side, and no matter how we turn it any other way, it is solid, so there's no path. The one straight below, for sure, it has a path. We can see a hole right through there. But on this side, there is no hole. It is completely solid. And that is the same with this port right here. So they work very similar as far as how they're designed. Now that holding port's not always in the front. Sometimes on other brands, they'll be in the back. For example, the one that comes straight down, that's what we hook our hose to our gauge with. So this will send pressure to my gauge. The one on the back side is where we hook it for holding our extra hose. If we see on the back side of this one, they are also solid, and we look at the one straight down, they actually connect somewhere. So that's a very important concept. And the reason that's important is because I've seen students that are new to the school or new to the trade even, and maybe they've only used one kind of manifold. Maybe they've only used this manifold right here, and then they go to use this other manifold and they get mixed up by which is in the front, which is in the back. And I've literally seen this happen. They'll unscrew this piece and try putting this on the unit. Well, this doesn't go anywhere, so even if you could get pressure, nothing's going to show in the gauge because the gauge is still reading 0. And they'll say, Mr. Ty, this unit's not working right. And so we have to show them again, remind them that we hook it here, the one straight down connects to the manifold gauge set, and this side is for a hose. Whether it's in the front or it's in the back, the one that's angled is just simply holding your hose. So don't make that mistake because it can be embarrassing. You are going to make mistakes, so you're going to have to just deal with that, but you want to minimize those as much as possible. So all this does, this gauge, when I hook it up, gives me the pressure reading, and I need to convert that pressure to a saturated temperature. Now, I don't need to open and close this for any reason while we're just doing our basic checks. Later on, when we're going to do vacuum and recovery, we're going to talk about opening and closing these ports. But right now, all we need to do is just get that pressure, convert that pressure to a saturated temperature. Now, if we look on the end, this port right here is open. And if I close this, which is what it needs to be when I start it up, you'll see that white piece show up in there, and that is a Teflon that's sealing that hole up. So when we have this hooked up, we want to make sure that these are always closed. If I tried to hook this one up on the unit and left it open, refrigerant would flow out of the hose and out the side, and it would be leaking, which we don't want to happen. So we want to make sure that this is closed. And the same thing on our basic manifold set. We always want to make sure that both sides are closed. Now, to see how that works, we'll open up the suction side, and we have this port is connected to this port, and actually this side also is completely hollow. This is the fitting that fits inside of there. These are actually our seals. This seal connects it to keep from leaking out of the handle, and this seal seals it up against the end, the edge over here. So if you ever have a manifold gauge set that's leaking, usually you can just tighten up this nut and you're okay, but sometimes you have to replace that seal. But when this screws in, it seals off to the hole that we see right there. And when we unscrew it, it opens the hose to the center port. The manifold itself is just simply a piece of brass with a hole in it. And this hole connects to this hole to a center or third port. And that third port has its hole in it as well. So it's very, very simple in design. I've cut this out with a chop saw, so it's pretty ugly the way it turned out, but it still gives you the idea this front one doesn't go anywhere. This center hole opens to the sides. So that's our manifold gauge set. It has this hook on it so we can hook the gauges while we're working with it, but it's very basic. We still have our suction gauge independent, and we have our high side or head gauge independent of itself. So let's look at a little different brand that's very similar in design, but I've cut it open a little differently for your viewing pleasure. Now my dad's a machinist, so he also was able to machine this open, and the black part that you see in the very center, that is our manifold tube where the refrigerant would flow. So we'll look at the high side first. Here's where my gauge, my hose will hook up. On the back side, this one doesn't go anywhere. So once this hose is hooked up, it's always reading pressure between these 2 points. And if we see right here, there's a little groove right there. So it comes from this hose around the groove to the pressure gauge no matter what. Now right now, this is sealed against a bar right here. So I'm going to back this off, and as we loosen this, you can see how now that hose or the hole is connected to the very center port. So when we open this or close this, it connects it to the center port. For some reason, a lot of students think that you have to open this to get pressure to the gauge, and that's simply not true. I want you to understand that now. Now this particular one, we also have a missing O-ring. So that means refrigerant is going to be leaking out of this handle. It's going to be an issue. This one does have the O-ring still in it, so it's important. But we've also broken the handle. What's cool is these things can be completely rebuilt. We can buy new gauge sets, new ends. I'll show you how we take this one apart. If we unscrew this end, this slides out. This is the piece that's moving, and if we see, there's a little groove right here, and that little groove allows us to slip this piece out, and you can order a new replacement piece. This particular brand uses 2 different O-rings right here. That's what seals it here, and then this end is a piece of Teflon, and that Teflon pushes against this little edge right here. So new techs notoriously will over tighten these, and it will wear it out because they tighten them so much. Now as these get old and over time of just setting and releasing, they'll eventually wear out, but there's no need to wear them out prematurely by over tightening them in there. But you can, if you do rebuild it, you can buy this new little end. You just slide it right back in like so, screw it back together, and you're good to go. You can buy new handles and new gauges as well. Now let's take a look at the gauge set. Few things that are important I want to show you on here, and one of those is going to be where this is pointing to. Now these are actually adjustable, so where this little screw is, I can turn this and it's going to turn that needle, so I can calibrate it. Now most people calibrate this to where that needle is pointing at 0, but there is another way of calibrating it. What you can do is take your hose and hook your hose to a refrigerant tank. If you use a brand new tank of refrigerant, you got to make sure it's liquid and vapor. If you have liquid and vapor, you're going to be at saturation. So that means it's going to follow the temperature and pressure chart. So now if it's at saturation and you know the temperature of the tank, you automatically know without a doubt what the pressure in the tank is going to be. Let's say it's at, we'll just throw a number out there, say it's at 100 psi. Then when the gauge is hooked up to this tank, I'll adjust the needle to where it's right at the exact corresponding pressure. But that's just a minor detail. The other thing I want to point out is the difference between these 2 gauges. This gauge here, it's a metal housing. They sell covers for them. This gauge, it actually came with its own cover. We're going to pop this cover off. And we're going to take our little cover off that we had that we're hiding from you in earlier videos. And we're going to take a look at these 2 gauges together. So if you look at these 2 gauges, there's some similarities and differences. One of the similarities are they're both compound gauges, meaning they do positive pressure and also vacuum or negative pressure. Vacuum's always in inches of mercury. Hg is the periodic table symbol for mercury, and it says vacuum. And over here it says inches of mercury vacuum. So that's very similar. We have different colors, but the biggest difference is this one goes to 250 and has an overpressure of 500. This one goes up to 120 and has an overpressure of 350. So that's going to be very, very important. If I took this pressure gauge and tried to use it on this unit, I could peg the gauge out and damage this gauge, which is an issue. We don't want that to happen. This gauge is designed for typically R22, R12, and R502 refrigerants. Much lower pressures. This one, designed for 410A, I can still use this gauge for R22. I can use it for 410A, 404A, or 100 other different refrigerants. This one will go to a higher pressure. So I could use this one on any refrigerant. This one I could only use on a lower pressure refrigerant. Now there is a benefit to using this gauge. If we try to see on this gauge, I wanted to find, say, we'll say 55 degrees. So here's 50, here's 60, 5 is going to be in the middle. It's very easy to see that number. Now if we wanted to find 55 over here, it's going to be a little bit more challenging. We have 50 and then we jump to 75. All these gauges are a little different, so we got to count between them. Let's say maybe 10s, 50, 60, 70, 80, 9, nope, that's not it. We'll try 5s, 50, 55, 60, 65, 70, 75. So each one of these are in 5s, so 50, 55, 60, so it'd be that first mark past the 50. And if we look at how thick that needle is, it's hard to see exactly where we're at. Then if we want to convert that to a saturated temperature and try to see that number there, the thickness of this gauge compared to how small that number is, almost impossible. So these are horribly inaccurate just because to get enough pressure reading on here, we have to have these spacings a whole lot closer together. And now we can't accurately see the number as well. So that's one of the reasons that we don't like to use these analog gauges, is because of the lack of accuracy. Now, as we're talking about this is overpressure, which means it's a safety. You can get up to 500 without completely destroying your manifold gauge set, and that's okay. Now, in the older days, they called this retard pressure because it was just simply a maximum pressure. It wasn't meant to insult anybody, and I've had students before that get really upset about that, but that's just what they usually call it. Now, to be friendly and universal, we call it overpressure side. So if you hook either one of these gauges up to a system that's off, your saturated temperature could be over here in this range, and it's still going to be okay. So this gauge is called a compound gauge, or a suction gauge, or a low pressure gauge. This gauge is called our high pressure gauge, or also called the head gauge, or the liquid side gauge. It's all very similar in terms. But how these work is pretty cool. So we're going to open the back side up and check it out. Now in the back side, see how this tube is in the shape of a question mark? And we see inside all these fine little gears. If we add pressure, this tube wants to try to straighten out. And as it tries to straighten out, you'll see it moving these little bitty gears. And what it does on the other side is it moves that needle. So this tube actually has a special name. It's called a board-on tube, and it's kind of some worthless information that for whatever reason is on many different certification tests, but it's just very cool how it works, very simple. It's like clock-style gears inside of here that make that work. In the older ones, you would see a lot of these with plastic, and the plastic would notoriously break. I always preferred these metal ones because they held up a lot more robust. Now, in my day, we had these gauges that were liquid filled, and they were filled with glycerin. And glycerin was the go-to gauge. You were the in if you had the glycerin filled gauges, and they looked really cool. And I was like, man, I have to have one of those sets. So I bought the glycerin filled gauges, and I hated them because the glycerin would always leak out, and it would leak all over everything. And they were so much more expensive, and it didn't last any longer. The moral of the story is, just because something new comes out doesn't always mean that it's better, but you do have to keep up with the times and change as we go. So these are different gauge sets. That's the basics behind these work. 3-port standard manifold gauge set has been around for a long time. Now let's move on to the next version. So then enters our 4-port manifold gauge set. So here we have 3, it's low side, high side, and then our service port. Over here we have our low side, our high side, and we have 2 different service ports. So this had some advantages, whereas this one we just simply had 2 knobs. This we have a knob for every single port. Just like with this manifold gauge set, when you hook your hose up, it always gives pressure to your high side. On your suction side, you hook your hose up, you always have pressure in your suction side. Just like this manifold gauge set, when I open this valve, it connects this port to the very center. If I open this valve, it connects this port to the very center. We're not going to be opening and closing these right away. Later on we will, but this one had its own valve for this port, and if I wanted to charge a system, I could hook the hose up there and it gave me more control. On this one, if we're pulling a vacuum in a new system or a system we're doing some pretty invasive work with, we have a larger hose on this so we could pull a vacuum faster. So I could open this valve and it would connect this hose to the center. So by opening this valve and this valve would connect these two hoses and any possible combination you can think of between it. One of the things that was nice about this one is it had a physically larger gauge set so you could see the numbers easier. The other issue though, they were a little bit sometimes more bulky. You can see it took up a whole lot more room. And the other issue is they were heavier, especially with the extra hoses on it. Our hose ends hooked to the back. This is just to support it. And if this one, you can see that there's a whole lot of play in this. Now, technicians are notorious for hooking these in their van, and these bounce around and vibrate, which is very hard on these manifold gauge sets. These are fragile pieces of equipment. They have to be taken care of. I hear people that say, I don't want digital because they're too fragile. Well, these guys were way more fragile. This one, you can see it has tons of play in it, and our pressure is really far off. It should be over here at 0. This one should also be at 0. Now, the reason that this one is like that, this is in very good shape. I've kept this in really good condition through my entire career, but I was working for a school in Phoenix, and they used my entire tool set to start the school, and they damaged and destroyed a whole lot of my equipment, and I lost a whole lot of money on that deal, and the school never paid me for that. But the moral of the story is don't let anybody use your tools, not even for the weekend, not even for one-time use. This is also why getting into the trade, you have to buy your own equipment because nobody wants you to break and mess up their new equipment. And employers stopped buying equipment because it wasn't theirs, employees would break stuff. So you need to make sure you don't loan your equipment out and you take care of your stuff, your parts. So here's another example of a 4-port, 1, 2, 3, 4. Little difference is we have metal knobs instead of the rubbery knobs. That's personal preference there. The big difference on this is we have a sight glass right here. So if I'm flowing refrigerant across here, I can actually see the refrigerant boil and change state. Or if I'm doing a recovery, I'm pulling the old refrigerant out, I can actually see the condition of that refrigerant to see if there's any black stuff in there, if there's any contaminants in there, any moisture in there. So it's pretty cool having that little accessory. Also, this is a larger gauge set. You can see it's significantly larger than the other one. That gives me more room for more numbers, and it is adjustable. I pull this plug out and I can calibrate this gauge set. But it's just a simple 4-port manifold gauge set. My hoses hook here. It's still aluminum, still kind of bulky, but it is a progress in our evolution of gauges. On to the next gauge. Here's our next gauge set example. These are digital gauges. So if we turn these on, we see them both light up. They'll go through a zeroing process, and both of these are really nice. They're much more accurate than the other gauges. They're very robust. They got good protection on the sides, rubberized, and they also have lights on them, which is really cool. We can turn the display on, see it a little bit better, especially at night. But the issue is you got to have batteries because batteries always fail. But every technician usually has batteries anyways. Here, this one's a 3-port design. This one's a 4-port design. This one, they both have the sight glass, which is cool. This one, instead of having knobs on the side, everything is right here on the front. So if I want to open my high side to the center, it's right here, and my low side to the center right there. It's very simple. What else is cool is they have the little hooks that fold out so I can hang them if we want or if we need to. And let's go to the really big thing that makes these so nice. Here we have our PSIG, and that automatically converts us to a saturated temperature. We don't have to have a temperature and pressure chart. We just choose our refrigerant, and it automatically gives us a saturated temperature on the fly. No charts, no apps, no conversion. It's really awesome. This one does the same thing. Here's my pressure, converts it to a saturated temperature. So there's a huge fight in the industry over whose meter's better. There's testo people, there's field piece people. I have them both. I use both. I have my own personal preferences, but ultimately, I don't think you can go wrong with either one. Both of these also connect Bluetooth to your phone and do a whole lot more stuff. One of the differences, this one's a lot smaller. People like that. The other difference is this one's bigger and has more stuff on one screen, which some people like that as well. They both have their gives and takes. take care of your manifold gauge set. It will last a long time. And these are going to do way more than just convert temperature and pressure. As we go through this program, we're going to show you more about what this stuff does, but I'm going to show you the manual way first. Then when you see this and see how easy it is, you then have a great appreciation for it. So digital manifold gauge sets, love them. They're great. Usually have to buy them, the hose is separate, but there is still yet another option. Also, we have an option like this. These are individual pressure. This particular brand, Appion, is known for some quality. Some people like them, some people hate them. But what I can do with this, if I have a manifold gauge set that I absolutely love, I can actually unscrew this gauge set, and the threading that is on here is the exact same threading as the gauge. So I can convert my old manifold gauge set to digital. This particular model is also Bluetooth, so it'll convert pressure to a saturated temperature on my phone. And who doesn't like the cool apps and new stuff? Well, I do know people that don't like them. So since I have this set that was damaged, I could unscrew this, put my digital set on there, and now I'm with the modern times. But the problem is I'm still using these manifold gauge set with all these hoses, and most of the time we don't actually even need the hoses. So there's another solution. One of the solutions is we can put this adapter on like this. If I put this adapter on, I can put my hose right on the end. I can hook it to the unit, and I don't have to have a manifold gauge set at all. Most of the time we're not charging or recovering our vacuum, and it's very simple, fast, and easy for us to do. And yet there is even a better option than that. You can get this adapter here, and this goes straight onto the unit itself. By putting this straight onto the unit, I don't have any refrigerant loss out of those long hoses. It goes right onto the unit. The problem is they don't always fit. Sometimes you have to put a 90 on to get it to fit up and gets that unit. But it's really cool because this way I don't have any loss at all on the hoses. It's much faster, it takes up much less space. Connect this to my phone, have all my connectivity. It's really awesome. So there's even a newer product than this. Now, I was determined not to buy any more manifold gauge sets as I have plenty, and they all simply do the same thing, convert a pressure to a saturated temperature. But I've been doing a lot of consulting work for many other companies, and the new thing is now these filled piece probes. Testo makes them too, but what these are really great at is I hook them up to the unit. They already have a little 90, so they fit in almost every possible scenario, and they Bluetooth to my phone, high side and low side. You can use this app with the filled piece app. The Testo has their own app. My favorite app is an app called MeasureQuick, and MeasureQuick adds a whole lot of these different probes together, and you can do a full report on a unit right on your phone. You can buy that report and send it straight to your customer. So this is my next tool I was going to buy. I did purchase it. They're on back order, and I wasn't able to get it in time for this video, but coming up soon you're going to see me using videos with these probes. It is the newer thing. Some people love them, some people hate them, but ultimately it doesn't matter if you're going to be using the newest probes, the digital style, the analog gauge set, 3 ports, 2 ports, straight hoses, old manifold gauges. It really doesn't matter what you're going to use as long as you're going to be converting pressure to a saturated temperature. That saturated temperature is important. PSIG converted temperature. I have a low side saturated temperature and a high side saturated temperature. I want to know where the refrigerant's boiling at. I want to know where the refrigerant's condensing at. I want to make sure that's warmer than the air temperature on the outside and lower than the air temperature on the inside. This is refrigeration. PSIG, converted temperature. As we go through and do more and more stuff, we'll show you this equipment in action, and you can make your own decision on what is your best preference.